Hey guys, this is Mr. Bennett, and this is Unit 5, the Periodic Table, Video 5-3, and we have three major topics to talk about: atomic radii, electronegativity, and ionization energy. So our first topic, atomic radii, sounds a little complicated, but if you have any knowledge of geometry, then you know that when we look at circles, which is really kind of like an atom is a sphere, right? Anytime you measure a sphere or a circle and you're trying to figure out the size of it, the value that you're looking for is the radius, which is simply the distance from the center to the outer perimeter. So with an atom, we're measuring the distance from a nucleus to the edge of the electron cloud. Now, electrons are hanging out in this electron cloud, and realize that the reason why they stay close to the nucleus is that the nucleus has a positive charge and those electrons have a negative charge. But if you think of distance, as electrons get further away, as they get further and further away from this nucleus, the nucleus doesn't quite have as much pull on the electron. It's not as attracted as much. So if this is the first energy level, and then we look at the second energy level, an electron out here in the second energy level will be less attracted to the nucleus because it's simply just further away. If we continue to move out to the third energy level, an electron out here has even less attraction to the nucleus. And we can continue to go out here to 4 and 5 and 6 and 7 different energy levels. An electron all the way out here in the seventh energy level is very, very far away from the nucleus, which means it has not even nearly as much attraction to this atom as, say, an electron in the first energy level. Okay? The closer you get to the nucleus, the more pull the nucleus has due to its charge. So, what does that mean? Well, first of all, in terms of just sheer distance, right? As electrons are found in higher and higher energy levels, the atom is essentially bigger and bigger. So, as you go down a group, right, you're going to be going up the energy levels, right? Which means atoms are going to get bigger because their valence electrons are in higher energy levels. Right? So that's the first idea of atomic radii. If we continue this idea, as we go across from left to right, meaning across the period or the row, so for instance down here we have lithium, okay? Lithium's electrons are in the second energy level, it's 2s1, right? As we go across from left to right, we go to beryllium. Beryllium is 2s2. So we've added an electron, but we've also added a proton, okay? Another thing to notice is that these electrons, whether you're talking about lithium or beryllium, are still in the second energy level. So if we continue over here to boron, boron is 2s2, 2p1. It has 3 electrons in the second energy level, okay? But they're all in the second energy level, which means in terms of distance from the nucleus, they're all pretty much the same distance, okay? What is changing along with this? The number of protons. So as we go from left to right, not only are we adding electrons, but more importantly, we're adding protons to the nucleus. The more protons you have in the nucleus, the more positive charge you have. Which means the pull of the nucleus is going to increase. As the pull increases, electrons are going to get pulled in closer to the nucleus. What does that mean? That means as we go from left to right, atoms get smaller. So let's put the two ideas together. What does this really mean? Okay, well, we said that as we go from left to right, there we go, as we go from left to right, they get smaller because we're adding protons, which means more protons pulling on those electrons, so they get pulled in closer and closer to the nucleus. We also said that as we go down, electrons or valence electrons are found in higher and higher energy levels, which are further and further away from the nucleus. So going down, things get bigger. Okay? So if going to the right makes it smaller, going to the left is going to make it bigger, right? If we take this idea and this idea, we put them together, that means that on the periodic table, as you go down and to the left, atomic radii gets bigger. Okay, so your largest atom is right here in the bottom left, and your smallest atom is up here in the top right. Now the phrase that pays, meaning the phrase that will help you remember this, is that France gets fat eating French fries. In other words, francium is the fattest or the biggest of all the atoms. Okay, so what I want you to do right now is I want you to take a look using this idea and figure out, or practice, putting elements into the correct order from largest to smallest. So pause the video and see if you can put these in order. Okay, hopefully you pause the video. What I like to do when I do these problems is I circle them on the periodic table. So first element they want me to look at is carbon, and then I got calcium and manganese, cesium, aluminum, and barium, which is all the way down here. So they want largest to smallest, and we know that France gets fat, so anything close to the bottom left is big. So our first one, our closest one, would be cesium, right? Now the reason why I start with cesium and not barium is that cesium is a little bit smaller than francium because it's up one energy level, but it has the same number of protons. Okay, so then as I go to the right one spot to barium, it's going to get slightly smaller because we have one extra proton. Then calcium is going to be the next smallest because it has its electrons in the 4th energy level compared to barium's 6th. And then as we go to the right, we add some protons. Things get a little smaller. We get to manganese. Then as we go up one row, we get to aluminum. Has one less energy level, so it's smaller. And then finally, calcium. Or not calcium, carbon. What am I saying? Carbon. Okay, so that's our correct order. Now, this is the first idea. We still have 2 more ideas, but I'm separating this video into 3 parts. Okay, so that way if you need to go back and review, you can just look at this part. But make sure that you go on, if this is your first time, and you watch ionization energy.